So now we are going to discuss the topic of array correlation matrix. So in that see here, so now here we need to analyze this m element array with arriving signal. M element array with an arriving signal. So now first thing here you in the diagram see here the theta angles of each arrival signals are mentioning here. So that arrival signal is represented as x to xm. So based on that arriving signal, we are applying the weighted values also. So now this weighted value and that arrival of signal, it will be correlated and generate the matrix. So now see here in that antenna design, array correlation matrix quantify the statistical relationship between signals received at different elements of an antenna array, crucial for performance matrices like MMO capacity and beamforming. It helps mutual help coupling, and also it will be guiding element placement spacing to minimize it for better efficiency with low correlation, and also it improve the system performance. So we can calculate the array output and radiation out pattern also. The above figure depicts the receive array with incident plane waves from various directions and D signal arriving from D direction. So they are received by an array of M element with M potential weight. So each received signal xm of k include additive, zero mean, Gaussian I. The time is represented by the kth time sample. For example, that x1 of k means the k value is represented the time sample. The next thing, how we can define this array output. So see here, this is the equation for array output. Now y of k is equal to omega t into x of k. So now you have to apply the weighted value of your signal. So here that x of k is nothing but you have to include that angle of theta with that signal parameter. So now here how you can correlate these two things. See here how it will be mixing here. So now this S of k is nothing but that vector of incident complex nanochromatic signal at the time k, and n of k is nothing but noise vector at each array element m, zero mean and variance sigma n square. And a of theta is nothing but m element array steering vector for the theta I, the direction of arrival a bar, and the D matrix for steering vectors. So like that, each of the complex arrival at the angle theta I and intercepted by the M antenna element. So it is initially assumed by the arriving signal is monochromatic and the number of arrival signals are D less than M. So now we are going to define the correlation matrices. So now how to correlate the matrices? See here, let us define the M into M array correlation matrices. So the for that the RXS value you have to define here. So this RSS is nothing but source correlation matrix, and RNN is nothing but noise correlation matrix. So this is based on our basic identity matrix N cross N. So the array correlation matrix RXS and the source correlation matrix RSS are found by the expected value of respective absolute values are square. So now if we do not know the exact statistics for the noise of and signal, but we can assume that the process is ergodic, then we can approximate the correlation by use of the time average correlation. So in that case, the correlation matrices are defined by Rxs is equal to 1 by k summation of k is equal to 1 to k x of k x power of h into k. Similarly, RSS is nothing but 1 by k summation of k is equal to 1 to k s power of k is h power of k. And similarly, the noise vector also. So when the signals are uncorrelated, obviously has to be diagonal matrix because off diagonal elements have no correlation. When the signals are partly correlated, RSS is non-singular. When the signals are coherent, the RSS becomes singular because the rows are linear combination of each other. So the goal of AO estimation technique is to define the function that indication of angle of arrival based on So the goal of AOA estimation technique is to define the function that gives an indication of the angle of arrival based upon maximum versus angle. So the function is traditionally called the pseudopotron, the pseudospectrum. That means we can define as P of theta, and the units can be energy in the watt. Thank you.